Hi to all the students. Hello everybody. Let's be in the chat. So I'll be just taking out all the names who are actually going to be always active. So over here I can clearly see we have Khushi, the moderator as well. We have Anjali, we have Abhirami, we have Hari, and a lot of other students would be joining. We have Lakshmi as well. So whosoever is going to be active in the chat, I am going to be consistently taking your names. I'll be interacting to you guys as well. So for those who are watching me for the first time, my name is Luv Mehan. I am a graduate of IISc Bangalore. If you haven't followed me on Telegram, do follow Luv Mehan JEE Chemistry, and if you haven't followed me on Unacademy, do follow me at @Luv Mehan. Okay, and where you will be able to see a lot of my free classes which are actually available as recorded, and upcoming live classes are also going to be available only on Unacademy platform. And now over here guys, you should be following up the Telegram channel of this particular YouTube channel, which is JEE English Unacademy. So do that. If you haven't done that yet, it's going to be, this link is going to be there in the chat box as well. Click it and join it, because all the sessions are going to be updated over there. And this particular month is too much feature packed, too much power packed for droppers as well. Do remember that. So when we talk about droppers, we are also talking about students who are going to appear for 2022 for the first time. So if there's anybody who wants to prepare for advance, there is a crash course from my side. For those who are really looking for 2022 classes, I am talking about whether it's solid state, coordination compounds, metallurgy, DNF, solutions, electrochemistry, chemical kinetics. Every chapter has been covered. So the complete 12th class physical chemistry has been covered by me, with all the courses which were running in the previous months live. And now these recorded lectures are also going to be available. And this month I am going to start the P block. So we are going to complete the P block in this month itself. So till now I could, by this end of this month, I will be able to say that we have completed the inorganic and the organic chemistry, or the physical chemistry, and we are going to start the organic chemistry as well. Right? So guys, if there's anybody who wants to prepare with a complete structured course, then you should definitely join Unacademy. And you should also remember my English batches are also going to be coming soon. By the time, you can also look for the Spark batch and the Shine batch. Shine batch is for 12th class students and the droppers as well. Spark batch is for class 11 students. So do remember that. And there is something really big again coming up for the students who are looking for a drop. So if there's anybody who or even one of you might be the one, if you are looking for a drop, let us know in the chat box. Write me and just wait for it. Something big is coming for you guys on Unacademy. And by the way, as I was talking about, there are some, so much things for droppers. Pay attention. If you would see, there are so many batches which are coming up for droppers. See, dropper to topper batch, drona batch, leader batch, and there's so many. And if you would see, on 1st September, 8th, 15th September, there are so many batches that are coming up. And you should know one more thing, that in the upcoming few days, I am going to be bringing up few free classes for you guys, where I'll help you to cover backlogs. So if you want to get alerts for those classes, you should be active in my Telegram channel. The Telegram channel which is there in the chat, the Telegram channel which is also going to be there in the description as well. Are all these batches in English? When we are talking about the batch in English, it's the Shine batch. Shine batch is there in English. Okay, clear? Give me a smiley in the chat and let's move ahead. And over here, you should remember, if you want to enroll in Unacademy with a good amount of scholarship, then do use the code LUVGURU. Guys, do write this code in the chat. LUVGURU. That's my code. And whenever you apply this code, the enrollment in scholarship test, which is the biggest scholarship test Unacademy Combat, it is going to be free. The enrollment is going to be free every Sunday, 11 a.m. 1 hour is what you have to dedicate. And as I am sure that each and everybody, buddy over here is actually talented, I am looking guys forward to see you guys holding up rank 1, 2, 3, so that you guys are getting 100% scholarship of 1 year Unacademy Plus subscription, and then 75% is also available, 50% and 25% scholarship is also available. No student should get enrolled without at least giving this particular test. Everybody should give. Okay, so do remember that. And apart from this, you should remember, when you come to study at Unacademy platform, you get Plus and Iconic, and there you get the India's best teachers. And over here you should remember, the classes are always live. Okay, so each and every student gets a chance to be there in live batches where they can ask the doubts instantaneously. Apart from this, notes and PDFs of the teachers are available, so you have to work slightly less on the notes making part, and each and every course is structured, so it ends at a particular time. It's absolutely so structured that you can always rely on these courses. Apart from this, live tests and quizzes are also available. What's extra in Iconic is that over here personal coach and study planner options are available. Study material extra would be given to you, the booklets, the content, the theory, everything, the questions. So do remember that in Iconic. An Iconic subscription I am going to recommend for 2022 and 2023 students. So 2022 and 23 students, 2022 students should go for 6 and 12 months, and 2023 students should go for 18 and 24 months. And the only code that you guys actually have to use to get your maximum discount, it's Love Guru, and whosoever uses this code, I mentor that particular student personally. So do remember that. Okay, I have been doing it for myself as well. I have cracked one of the toughest examinations with less amount of studies, with an all India rank of 361, and I want you guys to do it as well. By the way, how many of you are really dedicated to crack JEE, to become something much more better than what you are right now? Let me know in the chat. And by the way, have you really shared this session with others? If not, do that right now, and so that each and every other student should know that there is some other class going on which is really helpful. And apart from that, mark the attendance and subscribe the channel. Okay, and over here we are going to talk about the chapter is anyhow solid state, and we are going to talk about the electrical and the magnetic properties. Sir, when is S block and hydrogen? So if you are talking about S block and hydrogen, that is a class 11th. These both are class 11 chapters. If you're talking about doing it on YouTube, it will only happen on the days which are M, W and F. This is Thursday, where TTS is the timing for class 12th chapters. And apart from that, I will be bringing up all the chapters for you guys in my special classes. So do remember to follow me on Unacademy. Okay, now we are going to talk about the electrical and the magnetic properties. But why? Because if we will not learn about these properties of the solids, then how will we be able to use these solids in whichever manner we want to? Let it be in mobile phones, let it be in the case of insulation, where if I want some elements which should conduct electricity, to make some chips, I want something. If I want some particular solids to prevent me from getting electrical shock, I should know the properties, correct? We cannot use any random material. If I should know which particular element is going to get attracted or repelled or whatever in the magnetic field, we should talk about that as well, right? So yes, is everybody ready? Let's start up this class. Okay, so now we will be talking about the electrical properties first, and then we will talk about the magnetic properties. Okay, so now let's move ahead. Over here, whenever we talk about the electrical properties, there are three terms that we should know about the elements, about the matter, about the solids. So the first and the foremost one, which is super duper important when we talk about when there should be a element which should conduct electricity, it is known as conductor. What is it? The conductor, not the bus conductor. Okay, it's the electrical conductor. Okay, so do not get confused with the bus conductor, boys and girls. Over here, conductor. Now what is the value that you really have to remember for these conductors? Over here, whenever we talk about their conductivity values, it ranges from 10 raised power 4. Again, write it, 10 raised power 4 till 10 raised power 7 per ohm per meter. Why is that? Because you should remember, whenever we talk about the conductivity, what is the formula? Do you guys really remember that? So first of all, whenever we write resistance is equals to resistivity L upon A, is that what we write? Yes or no? If the length of the wire increases, the resistance increases. That's what we see. And if the area, cross-sectional area of the wire increases, it becomes easier for the electrons or the current to flow. Hence, this is the one. But when we talk about, let's take resistivity and the conductivity on other sides, right? So this is what will we do. Okay, so now what is this? This becomes the conductance. So I'm writing C for conductance. For this, I am going to write conductivity, and this is L upon A. I'm taking these on the. Yes, is this clear or is it not? Even that is, this is good, but as we are talking about the conductivity now, pay attention. K is equals to C, which is conductance, L upon A. So over here you should remember, whenever we talk about conductance, you can write it as, again back as per ohm. Conductance is per ohm, and this is, if this is meter, this is meter cube, meter square, sorry, meter square, and ultimately it is going to be meter inverse, and this is ohm inverse. So that's the reason the conductivity or the unit of the conductivity comes out to be. That's what I'm telling you, because whenever you do that, I mean, you should always know what was the formula, how is it coming up. So 10 raised power 4 till 10 raised power 7 per ohm per meter. It's too much high. We'll talk about how does this happens. We'll talk about the band theory as well. But now over here, whenever we talk about the semiconductors, the conductivity should be lesser. The conductivity is going to be lesser. And over here it is ranging from 10 raised power minus 6 till 10 raised power 4, where conductor starts, where the range for the conductor starts, the range for the semiconductor ends. Okay, 10 raised power minus 6 till 10 raised power minus or 10 raised power 4. When we talk about the insulators, so it is going to be lesser than 10 raised power minus 6. So now the range is 10 raised power minus 20 till 10 raised power minus 10. This is the range for the insulators. Have you written all of this in your notebooks? I do not expect each and every student writing up every sentence, but no, just write conductors, semiconductor, insulators, and the conductivity range. That's it. This is how you should make short notes. Yes, good. That's amazing, Anjali. I am really happy to hear that, see that. Yes, but now let's focus, okay? And by the way, everybody, mark the attendance here. You should be marking up the attendance if you're liking up the session, okay? Now, let's talk about the conduction. So whenever we talk about the conduction of electricity, what is, whenever we talk about electricity, what is exactly moving? We're talking about the movement of electrons, correct? And these electrons, where do they belong? These electrons are obviously present inside atom, inside the atom. But now let me know, if this is the nucleus, this is shell number 1, this is shell number 2, or maybe let's not say shell number 1 and shell number 2. Let's say this is the inner shell, this is the outer shell. Which electrons will be eligible to participate or to just flow? Which ones are held tightly and which ones are held loosely? The ones which are in the inner shell or the ones which are there on the outer shell? Let me know first of all. Come on. The valence shell electrons are more eligible, or the electrons which are in the inner shell are more eligible for, for flowing? Inner ones are held tightly, absolutely correct. And the valence shell are the ones which are going to be the ones which will participate, which will conduct, correct? So this is what you should remember. So now whenever we talk about the band theory, what you should really remember is you have to make a band, you know, like a chewing gum. You know, these chewing gums used to be there when I was a kid, rectangular ones. This is what it comes in my mind whenever I see a white color rectangle. Okay, but I do not remember the name of the chewing gum, so let it be. Now this one over here is going to be the valence band. Write it down with me. Now pay attention. Over here on the y-axis you have to make the energy. And there is one more band which is known as the conduction band. This is the conduction band. Okay. The energy value, what particular this diagram shows you, the energy value of the conduction band is way much higher than the valence band. But in the case of conductors, you should really remember that the valence band and the conduction band, they do not have the energy gap. They are overlapping each other. So something like this. So now I am going to make this one up for you guys. Do this one in your notebooks. Okay, pay attention. Something like this. I am trying to show you the overlap. See, I have overlapped. Which is the region which is getting overlapped? I'm making this for you guys. Pay attention. Cool, right? You should remember what exactly, what is getting held in the valence band. Valence band always have electrons, and whichever electrons are going to be there in the valence band having slightly higher energy. Which ones are having higher energy? The inner shell electrons or the outer shell electrons? Even if you remember the Aufbau's rule, you can give me a correct answer. Think about it. The outermost ones or the inner ones? Obviously the outer ones. That's the whole reason the electrons try to fill or sit inside the inner shells first, and the lower shells first. Then they get into the outer shells, and when they are trying to get into the outer shells, their energy value is anyhow more. So let's talk about these ones. These are the most energetic ones, but in the case of conductors, their valence band and the conduction band both are overlapping, the valence and the conduction. But now the electrons which are available in the region of valence band and the conduction band, these are eligible. And these electrons will flow whenever they are going to experience any external electric field. Yes or no? Is this really clear? Come on, boys and girls, let me know. Khushi, Abhirami, and Anjali, Hari, everybody let me know. Okay? Now over here, this is what we see. There is an overlap when we talk about metals, and metals are good conductors. So this is what you really have to remember. Okay? And now when we are going to talk about the insulators, you guys really have to give me one example each of an insulator around you. Okay? So let's see. Over here, pay attention. When we talk about the valence band and when we talk about the conduction band, in the case of insulators, there is a big amount of energy gap. How is it? So conduction band energy is required to be, let's say, this much. Okay, it's the level. But valence band is having too less the energy value. Energy value of the valence band is too less. And then it takes almost too much of energy to allow or to make the electron jump. And sometimes atoms cannot do that by their own. Hence, and by the way, you should always remember this particular valence band, which is written as filled band, is always having electrons. I'll let you know. Okay, how? So let's talk about hydrogen. Any atom that you say, it is having a valence electron. Hydrogen 1, helium 2, lithium 1, beryllium 2, boron 3, carbon 4, nitrogen 5, oxygen 6, fluorine 7, neon 8. So valence electrons are always there. Now it totally depends that what is the energy level. Are they, and is it really loosely binded with the nuclei, the electron? Is it like loosely attracted, or it is too much attracted with the nuclei? And when we talk about the metals, as they are electropositive, they are really not loving the electron. I mean, they do, but not as badly as electronegative elements do. Correct? So this is where the electrons are here. I'll do it with the red because it's white, right? So electrons are available over here, but having lesser energy. And in order to be eligible, in order to be in the conduction band, they have to jump way much higher, which they cannot. And hence, these electrons never become eligible, and hence insulators are having very, very, very less conductivity values. And what is the conductivity values? We will write it again. So valence band, which is always having electron, and when it has, when it has to go to the conduction band, the electron, it has to overcome that band gap, forbidden zone, all because of large energy gap. So what is the value of conductivity? Do write it down with me. Then only you will remember. Conductivity range 10 raised power minus 20 to 10 raised power minus 10 per ohm per meter. Clear? Amazing, Khushi. That's amazing. Now, let's talk about the semiconductors. Neither insulator, neither conductors. So what is it going to be? So it's going to be like, just like in conductors, let's talk about conductors again. The valence band, conduction band, overlapping. Correct? When we talk about the insulator, the valence band, conduction band, too much of gap. Then what about insulators? Valence band, conduction band, but the gap is very less. Guys, do you see? It's very less. Okay. So this small gap is very less. And in this scenario, you just remember, whenever we are making up electrons in the valence band, these electrons can be excited, and not all electrons, but few can jump. Not all, but few, just like this one. Not all, but if the band gap is going to be smaller between, the band gap is between this and this, then ultimately few electrons can jump, and these electrons will be eligible. And higher the number of electrons in the conduction band, higher is the conductivity. Lower the number of electrons in the conduction band, lower is the conductivity. No electrons in the conduction band, very poor conductivity. Do remember all of these. So now what can we do to make an electron excited? Can we provide temperature, heat? Yes. And whenever we heat it up, whenever we increase temperature, the electrons become much more eligible to jump. So do remember that. Okay. And what about the conductivity range? Write it down in the chat, just like Khushi was doing. Conductivity for semiconductors. And do let me know some examples of semiconductor. Let's see in the chat. But also, nobody gave me the insulator example, is it? Or maybe I just missed. So over here somebody said glass, cloth, wood, paper. Amazing. Thermos. What's thermos? What do you mean by thermos? Khushi, elaborate. Yes, 10 raised power minus 6 till 10 raised power 4. 10 raised power minus 6 to 10 raised power 4 ohm per meter for semiconductors. Amazing. Now let's move ahead. Over here, what are we talking about? Yes, whenever we increase temperature, electrons can become eligible if the band gap is going to be smaller from valence band to conduction band. So over here, conduction band and valence bands are not clearly visible to you guys. I'll make it up. Conduction band, valence band. Whenever the band gap is small, always remember that. Okay. Okay. Hi Vidya, welcome to the session. So now substances like silicon, germanium show this type of behavior. These are known as intrinsic semiconductors. Guys, do remember intrinsic spelling. INTRINSIC, intrinsic semiconductors. So do remember that. Okay, and over here you should remember, what are we talking about when we increase temperature? Their conductivity increases with the increase in temperature. And now let's talk about the doping. What is doping? In Hindi we can call it as मिलावट. In other words, adulteration, mixing. That is what we are talking about. But mixing with what? Mixing with different element. Mixing with the different element. And now what are we going to talk about this? Now guys, pay attention. So whenever guys are going to talk about, let's say, silicon. Now pay attention. How many valence electrons does one silicon has? It belongs to group 14, the carbon family. So just like carbon, even this is going to have 4 unpaired electrons. We'll talk about it. Okay, ultimately it is going to be 3s2 3p6 3s2 3p2. So now ultimately over here 1 1 1 1. Chalo. Now let's make one more silicon. Okay, 1 1 1 1 one more. Okay, so anyhow these ones are anyhow going to get paired. So 1 1 1 1. Do it for all. I'm just going to make 6. Don't worry. Cool. Now what exactly is going to happen over here? Now in the case of silicon that we're talking about, it is an intrinsic semiconductor. It shows semiconductor properties, but if we want to increase their conductivity, then what can we do? Now guys, pay attention. Over here, pay attention. Now we are going to talk about the doping. So instead of silicon, I am going to replace few silicons with a different element, and this different element is going to be, let's say, arsenic. Arsenic belongs to group 15, right? Nitrogen, phosphorus, arsenic, something like that. And you should remember the valence electron in arsenic is 5. 5. Okay? And ultimately, now let's make these 5 electrons. 1 2 3 4. As 4 electrons as it it was shown by silicon as well. But where is the 5th electron? Now guys, pay attention. Over here. This is the one. So this is the 5th electron. This one. I'm marking it up. Is there an extra electron? Do you think this extra electron, the 5th one, is it paired? No. This is not a paired one. This is a kind of free electron. And whenever the electric field will be applied, whenever this particular element, this particular compound, or the material is going to be there under potential difference, then ultimately this free electron that you see, which I have marked, so let's say there is a negative end over here, potential difference, positive, this electron will flow much easily. This electron will move much easily. The mobility will increase enough for the electrons, and then ultimately the conductivity increases. Now I'm going to look into the sir, can conductors be liquid? Amazing. Why not? So when we talk about the molten, metals, even they conduct electricity. And when we talk about, liquid, when we talk about water is a very bad conductor. It's an insulator. But if cations and anions are available in water, then due to the mobility of ions, a liquid can behave like a conductor. My doubt, TV is semiconductor. What do you mean by TV? Are you talking about television? No, television is a device, correct? Television or mobile phones or laptops or any other electronic, they have components which are going to be semiconductors. there would be some components, chips are made up of semiconductors, okay. A lot of different devices are made up of semiconductors, is what you should know. Circuit board has a lot of semiconductor. The motherboard that I'm talking about, the chip I'm talking about, not the whole device, but yeah, if you're talking about the cover, the casing of the TV, the plastic, if it is made up of plastic, it's insulator. Now let's talk about more. So over here, what is, can we say that this particular doping gave an extra electron? Extra electron means some extra negative charge to this particular pure silicon. Earlier it was pure silicon, but right now it is not. Extra electron, whenever you are going to provide group, guys pay attention, group 15 into group 14 with group 14 elements, then you are going to provide one extra electron, because group 15 elements are pentavalent. Pentavalent means they have a valency of 5, and these are tetravalent. These have 4 valence electrons, है ना? So ultimately over here, whenever we talk about the group 15 electron, of elements, these have 5 valence electrons, these have 4 valence electrons. You provide one extra electron. And anyhow, when we talk about group 14, group 15 and group 13, group 15 is the next, I'm deliberately saying next group. So this particular type of doping is known as N type. This one is N type, electron rich. You can remember N either by the next group, or you can remember N by remembering that there is one extra electron, the negative charge. So do remember that. But now let's talk about the different type of doping. So N type. So what is exactly happening? All of these, if all of these atom circles ones are silicon, this is arsenic, again having 1, 2, 3, 4 electrons, and the fifth one over here is the mobile electron, which is free to move. Okay, and this one is known as the N-type semiconductor. It's not just the arsenic if we are putting up. Instead of arsenic, if we put phosphorus as well, even that will show the N-type doping, N-type semiconductor. Okay, and now does the conductivity increases? Yes, definitely increases. But when we are going to talk about group 13 elements, if we are talking about the group 13 elements, so here is group 14. Group 14 elements have 4 valence electrons. Group 13 has 3 valence electrons. And when we talk about group 14 and 13, we're talking about the previous. We're talking about the previous group or the positive hole. Let's talk about, see, in both the cases P is coming. The reason I'm saying this again and again, so that it sits in your mind. What is the difference between N type and the P type? This is P type, okay? This is the P type one. Now, one less electron is what we are going to have. Silicon has been replaced, 1 electron of boron, 1 electron of boron, 1 electron of boron, and there is a cross. What's the meaning of this cross? Ultimately, the electron is missing. Now what's going to happen? So whenever we are going to apply electric field, potential difference, so what's going to happen over here? Now guys, pay attention. If this is negative and this side we are putting as positive. Now pay attention. This electron will jump here and will occupy the hole. The hole ultimately, will this electron be over here? No. Now the hole is going to be here. So the hole moves towards the negative potential and the electron moves towards the positive potential. Is this clear? And similarly it's going to happen. Okay, so this hole, positive hole, guys, positive hole where there is no electron moves towards the negative one, because ultimately this is getting occupied by the electron. Now if there is the hole, another electron will come and sit over here, and simply the position of the hole will keep on changing. Okay, cool. Yes, Khushi is not a ma'am. Khushi is still a student just like you guys. She's a NEET student from class 12th, and the reason she is moderator because she is a regular student. Okay, whosoever is going to be a regular student, I mean I do not have a problem making each and every person as a moderator, so you do remember that. Okay, if heating the atom, electrons are vibrating. Balaji, you have to frame your particular question again so that it becomes clear for me. Are you telling me, are you asking me, or whatever it is? Okay, chalo, clear, amazing. And now over here guys, pay attention. It can happen when you put boron, aluminium, gallium or indium, any of these, and dope it with silicon. What type of particular semiconductor are you guys going to see? The p-type semiconductor is what you have to remember. And now we are talking about the magnetic properties. Every element in the world, every substance in the world has magnetic properties. Now not every material is attracted by the magnets, but the ones which are not getting attracted or the ones which are getting repelled weakly, even those have magnetic properties. What type? There are total 5 types of magnetic properties is what we are going to discuss. So just like 5 problems, 1 solution. Okay, okay, let it be. Chalo. So now ultimately, why do all the substances have magnetic properties? Because the first and the foremost thing, each and every substance is made up of atoms, very tiny ones, but all these tiny atoms are having electrons, and these electrons are not in rest. And over here you should remember, if this is the nucleus, the electron revolves around the nucleus. That's one type of rotation. You have to use the right hand rule. So if the rotation is like anti-clockwise, the magnetic moment is going to be upward. Okay, and now when we are going to talk about electrons at any position for any instance of time, it rotates on its own as well, just like Earth. Earth revolves around the sun, that's the first point, and Earth also spins on its axis, right, like a top. So ultimately, even for an electron spinning on its axis, again a magnetic moment. So there are magnetic moments available due to the presence of electrons which are rotating and revolving. Okay, G Karthik, where are you from? Well, I am from Delhi, right now in Bangalore, and teaching you guys over here. Okay, and now over here guys, pay attention. This is the reason what we are talking about is each electron in an atom behaves like a tiny magnet. Its magnetic moment originates from 2 types of motion. One, revolving around the nucleus, and second, rotating on its axis. So do remember that. Tamil, anybody here? If there is anybody who is Tamil over here, let G Karthik know, otherwise he will not learn anything. Okay? Okay. Sir, my name is just only Karthik. Okay, Karthik Ji, but yeah, focus over here. Stop making relations right now in the chat because it won't help you. I mean, you can do it eventually when people would be here, but now let's focus over here. So again, there are 5 types of properties that we are going to talk about. On the basis of magnetic properties, substances can be classified as. So the first one, write it with me, paramagnetic, then diamagnetic, then the ferro, the strongest one, then the anti-ferro, anti and then the ferromagnetic, and then the ferri. These are the 5. Okay, whenever we talk about magnetic substance, what is the first element that comes in your mind? For me, it's iron, and iron is the ferromagnetic one, which are really strongly attracted by the magnetic field. We will talk about what exactly happens, but do remember, we are going to talk about these magnetic moments, these arrows that you see. Guys, do you see the arrow? We are going to talk about these arrows, the magnetic moment, the direction, too much. So now guys, pay attention. So whenever we're going to talk about the paramagnetic substances, in the absence of any magnet around, or in the absence of the magnetic field, what exactly happens? Their arrows, their magnetic moments are random. Their magnetic moments are random, okay, in any direction. These magnetic moments are vectors, okay, and these vectors are in random directions. But as soon as the magnetic field is applied or the magnet is closed, if the direction of the magnetic field, I'm going to make it for you guys, if this is the direction of the magnetic field, this is the direction of the magnetic field, then all the magnetic moments of that particular substance, what type of substance? Paramagnetic substance is what we are talking about. Their magnetic field aligns. Attention! Something like that, okay? All of them. But as soon as the magnetic field is removed, all of them, all of these magnetic moments becomes the same, random. But when the magnetic moments are in the same direction of the magnetic field lines, these substances are attracted towards the magnet. Okay, so you should remember that. Okay, these are attracted, towards the magnet. These are weakly attracted in the magnetic field, is what you have to remember. Okay, and when we talk about the examples, do remember some oxides: titanium oxide, vanadium oxide, more oxides, CuO, iron 3 plus, oxygen atom, oxygen molecule from molecular orbital theory, chromium 3 plus, etc. These are paramagnetic ones. Do not get confused. I told you, right? Iron. This is iron, Fe3 plus. This is para. But when we will talk about iron, we'll talk about that as well. Okay. Now we are talking about diamagnetic ones. Whenever the magnetic field is applied, they totally behave unlike the paramagnetic ones. Over here, these ones are weakly magnetized in the opposite direction, okay, in a magnetic field in the opposite direction. So do remember that, okay. It is shown by those substances which are having all the electrons that are paired. If there is no unpaired electron, then these substances are going to be diamagnetic, and that is what we have always learned when we talk about the chemical bonding, molecular orbital theory, or any other chapter where we see any particular ion or atom having zero unpaired number of electrons. So do write, it should have 0 unpaired electrons. That makes it diamagnetic. Okay, so do remember that. Okay, and now the examples: water, NaCl, benzene. Do remember those. Okay, I am also love in the chemistry, sir. Okay, ठीक है, amazing. So JEE English via Unacademy channel, maths live is not available. Maths teacher will be here soon. This is my big problem. Don't worry guys, even we are working for you guys day and night to bring maths teacher for you. So do not worry. We are on it. Okay. And now over here we're talking about the ferromagnetism. Whenever we talk about the ferromagnetism, it is more stronger than the paramagnetism. Do remember that. And over here guys, do remember what exactly happens. Let's say they have their magnetic moments in any way it was, but when we apply the magnetic field, let's say the magnetic field lines are upward, all of them align in the same direction of the magnetic field. Okay, but what if when we remove the magnetic field lines, what if we remove that? Still they do not change. Their magnetic field lines, their magnetic moments direction remains the same. They do not change it. In the paramagnetism, it used to become again random. In this one, no. So ultimately, do remember that, shown by those solids which are strongly attracted by the external magnetic field and do not lose their magnetism when the external field is removed. they do not leave their magnetism even when the external magnetic field is removed. So do remember that. Okay, and now over here, example, your favorite, my favorite, iron. More cobalt, nickel and few oxides like CrO2. Okay, amazing. And now, is this really clear, guys? Do you have a clear idea right now what is the difference between the paramagnetic and the ferromagnetic substances? Do let me know. Amazing, Hari. Now let's talk about antiferro. It's simply do not want a particular substance to act like ferro. So you should remember everything is same, but whenever it comes to, see, when the directions of magnetic field lines were random and you apply the external magnetic field, what exactly happens? Equal number of magnetic moments are going to be there, but opposite to each other. So now, up, down, up, down, up, down, equal number. This is a very important thing, because if you are not going to make it equal, then ultimately we will be talking about ferrimagnetism. You should know the difference between antiferro and ferri. We will talk about ferri as well. But now, guys, do remember, we expect these particular elements or atoms or molecules, ions, to show paramagnetism. And to show paramagnetism, there should be availability of unpaired electrons. But over here, what exactly happens? That they have equal number of opposite magnetic moments. Hence, they are not really attracted with the magnetic field. So ultimately, on the basis of unpaired electrons, we thought that it is going to be paramagnetic, but ultimately zero magnetic moment is available. And yes, so do remember that. Cool. Hari is writing paramagnetic. In the magnetic field, they align in the same direction when removed random directions again. But ferro always aligned in one direction. Their magnetism remains. And yes, when we are talking about the examples, oxides of manganese, MnO, MnO2, Mn2O3, NiO, cobalt. This is cobalt, okay? Oxide. Monoxides. Nickel monoxide, cobalt monoxide, and so on. Manganese monoxide is there. So do remember that. And now let's talk about the ferri. In this case, opposite magnetic moments will be there, but not in equal numbers. That's it. Okay? So now over here, these solids were expected to show large magnetism, just like ferro. They were not expected to be para. These were expected to be ferro, okay, due to the presence of large number of unpaired electrons. But in fact, small magnetic moment is seen, not zero. There is no, we cannot say that there is zero magnetic moment. There is, but again, these are having less. Why is that? Because ultimately in magnetic field, 1, 2 cancelled, 1, 1, 1. So just because of this, these two are cancelled. The effect I'm talking about. Just because of this, we are able to see the magnetism, correct? So do remember that. So please repeat the point. KBD, when did you join the class? Let me know. Because ultimately we are absolutely at the middle of the class and I do not really know when did you start and what you really need to know. So do remember that, guys. See, upward, upward, downward, upward, upward, downward. So what I can clearly see is the effect is getting cancelled. The effect is getting cancelled. We were expecting these two, this one and this one, to show us the same magnetic moment, but they showed opposite. And ultimately, only because of these two magnetic moments, there is less magnetic moment. Okay, so do remember that. They were expected to be something like ferro, but they didn't. So ultimately ferri. The ones which were expected to be para, they are but they couldn't. All the magnetic moments were opposite to each other in equal numbers, and then ultimately it is anti-ferro. So do remember those, okay? And yes, now a question for my the most excellent, the most intelligent students. Let's see. Sir, your live time, please. Sir, daily fellow for my JEE main advanced program. Okay, so over here, daily timing 9 p.m. is what you should remember. 9 p.m. Okay. Now let's move ahead. Over here, what type of substances would make better permanent magnets? Ferromagnetic or ferrimagnetic? Permanent ones. So for permanent, the particular substance should retain magnetism when the external magnetic field has been removed. Yes, minions, absolutely correct. For the physics, it's 6 p.m. For the chemistry, it's 9 p.m. And on special classes and on plus, I am taking classes on at 7 p.m. So do remember that. And now over here, finish time is not decided. You should remember that, okay? And ultimately, the ferro ones are going to be the one. So the ferro ones are the ones which can behave as a permanent magnet, right? So do remember that. And you should also remember one more thing. Guys, I am over here trying to give you the best, but even you are doing the best when it comes to self-study, correct? But once and for all, you guys might be able to experience a lot of doubts that are coming to you and it hampers your performance. Then this is where Unacademy is bringing up ask a doubt feature on Unacademy app, where you can ask unlimited doubts and at any point of time. So you will receive exact matches for the questions, because there would be a lot of students who have probably already asked this doubt. And you should remember, ultimately you will be getting up high quality video solutions. Wow, this time you guys are going to get high quality video solutions. And what if your question has never been asked and the video solution is not available? Do not worry again, we will still be making up these videos for you. But you should remember, if you want us to be efficient, so you have to ask one doubt at a time. Your doubt should be clear, all the options should be clear. You should just try to make in such a way so that whosoever receives your doubt, they are it's readable for them, okay? And you should tell us, you should take a picture or from gallery, snip it properly, it should be so much clear. And then ultimately you should tell us the subject as well, physics, chemistry, mathematics, biology, and send it. And ultimately you will receive the message as your doubt has been answered, okay? Is this really clear? Come on, let me know, boys and girls. Yes? And this is how you should remember that your doubts will be asked instantaneously. But do remember, do not post multiple doubts at the same time, and handwritten material should be avoided. So that, because sometimes the handwriting could be similar to a doctor, and it will be, so ultimately the doubt expert has to take your doubt to the chemist by then. I have also asked. So amazing. Ferro have stronger magnet. Yes, amazing. Correct. So is this really clear to each and everybody? If yes, thank you so much. We are absolutely at the end of this class. Do not forget to subscribe this channel. Do not forget to like this video and share it among your friends. I am going to be, regular for you guys at 9 p.m. and we will be covering up your syllabus. Okay. And do not forget to use the code LoveGuru on Unacademy platform whenever unlocking special classes, combats, and plus or iconic subscription. We'll meet again. I will be mentoring you guys whenever you use this code. So do not forget this. All the best. Take care. Bye-bye. Tata. I am going to be bringing up problem solving, daily practice problem solving things for you, sessions for you. So we'll do a lot of fun. Okay? Chalo. Bye-bye. I think I got a knowledge power increasing, sir. Lectures. Oh God, it's amazing. Thank you so much, Karthik. Bye-bye.